first part with the hands-on. Let's hope this is going to work. Okay, I'm hoping you can see my screen. Shout at me if there's a problem. I can't see you the way I've organized the screen. I'm going to just start with a couple of words about TopCat. I'm hoping that you've downloaded TopCat and installed it. It shouldn't have been a difficult problem. TopCat's usually fairly easy to install. I asked you to download the 4XMM-DR14 catalog and also the SLU catalog. I realized I should have also asked you to download 2 other catalogs. So what I've done is I've put them at the bottom of this first slide, but I've also got links further on in the slides if you want to wait, but I would suggest maybe trying to start downloading those 2 catalogs as well. They're fairly large. So the first one is the OM catalog. That's the link, and there's a QR code here if that can help you. And then there's also the 4XMM stacked catalog. So you have the detection catalog, but this is the stacked catalog, and that's the link at the bottom there as well. So as I say, those things will come back up again. So if you missed the link now, then they'll still come back up again in a few moments. So yeah, I just wanted to say a couple of words about TopCat. Hopefully you've installed it and had a look. Maybe you even know and you've used it quite a lot yourself. So TopCat is a tool. It's maintained in Bristol, and they're actually very receptive to receiving feedback. It allows you to view table data and also the metadata. So the metadata is the extra data that comes with a catalog that tells you about units from columns, description of the column. It also allows you to perform very simply statistics on your data, create plots of data, match, concatenate tables, and we'll be doing a lot of this now, hopefully, to perform different kinds of functions. You can also, which we're not going to do today, use it to link to the virtual observatory directly and integrate other tables that you've not downloaded. So yeah, those are the 2 catalogs. If you want to start downloading them now, that's a really cool thing to do. It would, because they'd probably take a couple of minutes to download. So the first thing we're going to try and do is to look at a couple of possible science cases that you could do with the catalog. Obviously, these are just examples. You can do many other things with them. So the first thing we're going to try and do is use the XMM-Newton catalogs to find clean objects. So objects that have got this flag that indicates that they are completely clean. Objects that have also got X-ray light curves. So we're going to try and do that as well. And that may be compact objects. So just to give you some information, if you're not a compact objects expert, compact objects often have high X-ray to optical ratios, which is why I asked you to download the OM catalog so we can get the optical information from that catalog. And they can also be strongly variable. So this is just a plot which I think is quite illustrative at the bottom, just so you know what I'm talking about. On the left are stars, their flux, and here's the variability. So the variability is a function of the flux of those stars. These are AGN, and these are compact objects on the bottom right-hand side. And you can quite clearly see that the compact objects are much more variable in the X-ray. So hopefully you've already retrieved the 4XMM-DR14 catalog before arriving, and hopefully you've currently got the SAS 6.2 version that's also downloading currently. So that's the link again here if you want that. If you didn't get the DR14, that's the link. And there's a QR code there for the SUS catalog, if you want to click that one. So what you want to do first is to try and cross-match the DR14 and the SUS 6.2 catalog in TopCat. So I'll let you open those things. I'm hoping you're going to be able to see my screen. Yes, okay. So you should be able to load your catalogs using File, Load Table. And that will take you to somewhere. If you click on the file store browser, and you can look through your directories. I have a million directories, sorry about that. And you can look through to find where the source you're interested, your catalog that you're interested in is, and then you can load it by looking through your list and loading it. I've actually already loaded mine, so I'm not going to do that again. So you should be able to load in the DR14 catalog and also the OM catalog. I'll give you a few minutes just to get you to load those things together. So if you want to cross-match a catalog, you can use the TopCat tool. On the top, there's a bar with lots of different icons. Yours might be slightly different depending on the version of TopCat that you currently have. But you should find a little icon that looks like it's two matches. Play on words, obviously. So yeah, not these kinds of matches, but yeah, we are going to make a match. And if you click on there, it will open you a new window and it says match tables. Yeah. And then I would suggest choosing a matching algorithm that's Sky with errors. So once you've done that, you will have some windows that open up and you can choose the catalogs that you're interested in. So you can choose your SUS catalog if you have it downloaded and your DR14 catalog. Yeah. And automatically it should find the RA index for your two catalogs. And if not, you can search for RA index in all of the columns. Yeah. So both of these catalogs have got a position error in theirs. That's the error on the position of your sources, and it's called pos error. And you can choose those as the error column. So the pos error actually is not 1 sigma radius. It's slightly smaller than the 1 sigma radius. So the idea being that you want to increase that to the 1 sigma radius. All of this information is in the all of the documentation that I indicated to you this morning. So to make it into exactly a 1 sigma radius, you need to multiply 0.1.0714. Okay. And because I think we should search out to 2 sigma radii, so not just 68% confidence, but to 95% confidence radius, then you want to do 2 times 1.074. So yeah, then you've got 2.14 and a bit. So that should be enough, just like that. Okay, so that would be the scale of our positional error. And then you can choose maybe the best match for each table one row, sorry. So that would match this table to that one, and using the things from here, and you can hit go. I'm not going to do it because I have actually done that already. Are people still able to follow in the room? Is it going too quickly? Is it okay?
Okay. Yeah.
Okay, cool. I should carry on. So if you match sus6 to DR14, the OM, and then match that to the detection catalog, you should have something like 205,000 matches. So this is quite a large table, and you'll see that you can look at the table if you want. You just click on your match. You can open the table and you can see all of the different data inside here. You can also see, for instance, each one of the column names by clicking on the metadata icon, which is this one here. So if you click on, again, just to show all of that data, you can see every single one of your OM sources, and it's been matched to all the columns from that catalog, and it's been matched with the DR14 catalog. So there's many columns in your new table that you've produced. So what you can do now is, because we said we were interested in objects that are X-ray bright, so if we make a X-ray flux divided by the optical flux ratio, so you can go to the last column or wherever you'd like to insert an extra column, and on that column you can click right, and you can make a new synthetic column. And if you do that, a window will open, and you can call that whatever you want. So I called mine fx_fopt. It would speak to me. And then you want to use an expression. So I've given you the expression here. The expression to use is the X-ray flux. Obviously, you can have another time, you can go and look through all the different kinds of columns that are available, but this is just to give you an idea of what you can do. You can use the X-ray flux, that's the X-ray flux column for band 8, so the whole band, 0.2 to 12 keV. And you can divide it by the V-band flux from the OM. So that's just the VB_flux. You can put a description in there if you want to remember later on what this is. There are no units because it's a ratio. If there were units, then you should fill in the units as well. And then you just click OK, and that will create you a new column, and that will literally be all of the, every time there's a value of X-ray flux and optical flux, it will provide that information in this column, which I've already done actually here. And then we want to find which are the really bright X-ray to optical ratio sources. So I just chose an arbitrary value of fx over f dot. F opt is about 10. I mean, you could use 100 if you wish to. There's no problem with that. And you can then create a new subset with the criteria. I've shown you the window here, and I'll do it again in a second here at the bottom of the slide, which you probably can't see because it's way too small. So you want to use your, whatever you called your fx or fopt column, and the greater than, I've chosen 10. If you wish to choose 100 or 50 or something, then that's up to you. And then we want to add other things on there. So that's the ampersand twice. So and. We mentioned we wanted to have objects that have got time series. So the column for time series is called time series, TSERIES. And then again, 2 ampersands. And then we want to have good sources, clean sources. So for the optical, for the OM catalog, you can use these flags. It's not perfect, but you can use this. V underscore quality underscore flag underscore ST is equal to, but twice, 2 equals. Open the speech marks, and then there's, I think, 13 of these. 2, 4, 6, 8, 10, 12, 13, exactly, yeah. And close the speech marks, and that's will choose you the clean sources. There's F because every single flag is false, i.e. there's no flag that's true, so therefore it's a clean source. For the X-ray sources, it's a little bit easier. You can use a sum flag equals to 0. So again, and then sum underscore flag equals 0. There's a number of different flags that you can use for your X-ray sources. There's 0 to 4. 0 is the cleanest sources that exist. 1 are usually fairly good as well. They're just maybe closer to some other sources that are a little bit bright or maybe causing some issues, and then it degrades down. Again, all of that information is available in all the documentation that you can get. So yeah, then you can create a new subset with those criteria. So you just write your little expression in here and then click OK, and that will create you a subset of the sources. Okay. So this is the subset on here. Right, I'm going to move on to the next slide. I should bring these things back up again. Hopefully you can see them. So then what you'd like to be able to do is to choose that subset. And if you plot them in a hammer Aitor projection. So how can you do that? So if you go back to the original top cat window, you can see there's like a sky plotting window. It's after the histogram and the open plotting icon. So this is the plotting icon. And you can open this. And then you want to look for the RA and the deck. Now it's modified those RAs and decks by putting a little _1 because there's an RA in both of the catalogs. So it wants to distinguish between the two. So you put RA1 and deck 1 in here. You can then choose as your subset. So you've created a subset. You can choose that subset that you're interested in, and you can give it a color. You can get rid of the other sources, and then you'll be able to see your things. So get rid of all and keep just your compact objects. I like to make them a little bit bigger. If you click on form, there's a size. This is size 1, it's small. Size 3 makes it just that little bit easier to see. And you can see them plotted here. We mentioned we wanted to make it into a hammer 8-off projection. So if you go to axes, we're on this main tab, and then we go to axes. The projection, you can just choose 8-off, and you can view it galactic. And then you see your galactic sources in the center of the galaxy. Perhaps don't regard the numbers that are written on here, but the center of the galaxy is here. So you can choose any of those sources, and if you click on one of those sources, it will actually come up in the table. So you've got your table of data, which I've lost on my screen. Oh yeah, I think it's. If I click on one of those sources, I'm hoping to be able to show you this at the same time. So say I clicked on this one here, it will highlight that source in the table. And then you can take those coordinates, and that's your source position, okay? And you can take them and copy them into ESA Sky and look at the different source products. So I was going to suggest you looked at this one here. That's one I looked at, and it had some products. So it's this one here, and it will highlight the source. And then you can just copy the coordinates and put them into the ESA Sky tool if you've got this ESA Sky tool open, or if not, it doesn't matter. So this is ESA Sky that we heard about a lot today, this morning. And you can copy, either you can type coordinates or you can give it a J value into here. And press enter, and it will display your source. And you can see it in any wavelength you want. So I've chosen the soft X-ray with XMM-Newton, but you can choose other wavelengths. Or not. Sorry. Obviously not. Things are not working on my screen now for some strange reason. But yeah, you can choose whichever you want. I'm not going to add one in. It's not working for me at the moment. And you can choose, say, if you wanted to look at it in OM or something as well. You can look at your source. It's very faint in OM, which is normal because we asked for a bright X-ray source and a fairly faint optical source. So ESA Sky is a fantastic resource. You can look at in any wavelength your source, and you can also pull up, say, products. So there's some RGS spectra that are available, for instance, for not this source actually, but it's a very nearby source. You can look at those spectra, for instance, by just clicking on the preview button. Often there's there's X-ray light curves from XMM and spectra. I think there's a problem at the moment because they're not showing up. And you can see so you can actually visualize those X-ray spectra or the RGS spectra or the light curves or whatever with the tool, which is fantastic. So this is one example of something you could do. I'm hoping you will be able to follow at least some of what was just done and get some idea about some of the different things that are in those catalogs. I'm going to move on to a second example. But as I say, I'll provide all these slides, and then you've got the information that's on those slides if you've not been able to keep up with the demonstration. So this is another example. I'm going to look for another clean source. This time, look for a point-like source in extended emission. And one way you might want to try this with the XMM catalogs is by taking the detection catalog, so the DR14 catalog, which you already have, and then cross-correlating it with a SLU catalog, which has got a slightly poorer resolution because the image needs to be reconstructed as the satellite slews across the sky. So again, if you've not downloaded the SLU catalog, that's the link to get to the SLU catalog. And if not, there's a QR code that's just here to look at the SLU catalog. So The same thing as we did last time, we can use TopCat to make a cross match between the two catalogs. So we can do that as we did before. So if we go back to the main TopCat window, if you load your SLU catalog in there, so if you remember that was file, load table, and then in the file store browser, you can search and find your SLU catalog wherever it might be. And then click OK, and that should then load. And then you can do the same as we did before. Go to the cross match tool, the little matches that we had in this icon. Again, we can do sky with errors. But the SLU catalog, like the detection catalog, actually has an RA-DEC error, which is the 1 sigma error. That's good. So we only need, if we want to use a 95% error radius, just use a scale of 2. So you can choose the RA and DEC for both of those objects, and then the RA-DEC error for those catalogs, sorry. And just use a scale of 2. So we're using the algorithm sky with errors, as we did last time. A scale of 2. Choose RA and DEC and RA-DEC error for each one of the SLU catalog and the detection catalog. Once you're ready and you've done that, you can click go and get it to start doing the cross match. So once you've created your table, you should have your match. And again, you can visualize that table using this button here that shows you all of the different table data, each cell of the table. Yeah. And as we did last time, we want to look for some sources using a subsample. So you can go back to your TopCat main window and go to the subset icon, which looks like a Venn diagram of some kind. And you can click on there and you can create a new subset by doing the plus. So define your subset, whatever you want to call your subset, give it that name. I'm going to point in extend as a name. And then both catalogs distinguish between point-like and extended sources. So you can use the extent of the SLU catalog in the band 8, which again is the 0.2 to 12 keV band. And it considers anything above a size of a BSF size of 6 to be extended. So we can use ext_B8, which is the column name, greater than 6. And we want only the clean sources, which is what we just mentioned earlier. So for the SLU catalog, to find the clean sources, you want to use the val flag, which is equal to it's called clean sample. So you want to use that. So remember, you need the 2 ands between each one of your criteria. And then if we want to find the point-like sources in DR14, we can use the epic extent. which is less than 6, and that makes it a point-like source. And as last time, we want to use a clean source, so 2 ands, and then we give it the sum flag equal to 0, and that will choose all of the cleanest sources in the DR14 part of the catalogue. So that's what that looks like, the row subset. And then if you click OK, that should make you a sum. Oh, what have I done wrong? Sorry, I have done something wrong. It's not flag. Sorry. Made a mistake in the what I typed out. Sorry. You can see all of the columns, as I said before. You can see them in this metadata, and you can look for it's val underscore flag. It should be right. Oh, it's val underscore flag. Excuse me, I missed the underscore. That's what it was. Val underscore flag. I will change the slides before I give them to you, and then you can click OK. And then you should have made a new subset, which is here. It tells you how many is in there, and then you can also plot those should you wish to. So we can plot those as we did before in a hammer Aitor projection. So we click on this globe that we did last time, look for the RA and deck, plot all the sources in RA and deck. We can go into the subsets, find your point in extended or whatever you wanted to call your object, and you can plot those and get rid of the other guys. And there's very few, which there should be. Again, I'm going to increase the size of the form of the shape. Let's make them really big this time. And we said using axes, like we did last time, plot the hammer Aitor projection in galactic coordinates. So you've just got a few sources. That's very small. Let's see if I can get a bit bigger for you on the screen. You've just got a few sources now that we've narrowed that down. So those sources are extended in SLU, but point-like in XMM, because XMM's got a better resolution in the detection catalog of XMM, excuse me. This is the cross correlation, and you can choose one of those sources. So I suggest you take the middle source there. If you click on it, again, obviously nothing's going to happen. It should highlight in the window the source that you've chosen. Nothing's happening, obviously, because I'm making a demonstration. Okay. So anyway. Normally, as we saw in the last one, it does work. It does click, and you do find the information, and you can find your source. Hopefully, it's worked on your screens. You can find the source that's in the center of this field of view, and then you can look all the way along here, and you'll find a column which is called ident. For identity, and it actually will give you the identification. It's the tentative identification. It's not 100% good. It gives you an identification of your source in this column. You can also, if you wish, plot your source on ESA Sky. And if you plot the source on ESA Sky, over these things, whichever source it is, you can click right on there, and you can go to Simbad and use that to identify your source, for instance, and then you'll get the closest source this is not the source we were talking about, but this is this one. So hopefully you've been able to do that.
Can you please repeat what you got from podcast?
I can't hear. I don't know if the question was addressed at me, but I can't actually hear you very well.
It's asking how to go from ISA, no, from TalkTap to ISA Sky.
Yeah, so you can actually do that, and I'm not going to do that because it would take a little while to set it up. So I would just suggest opening ISA Sky in your browser and then putting the coordinates of your source into this top right little box that you have. You can do that, but yeah, I think it would just take too many steps now for us to do that. It's already been complicated enough, I think. But you choose the value of the RA index that came up when you clicked on your source here, and then I think you should have been able to identify your source, hopefully. Okay, that one's got it there. So this one, hopefully, yes. It should have highlighted your source in there. Yeah, there you go. This is the right source. And it's given me this identification. And then you can use the RA index that you've got here and copy that RA index. Control C to copy, and then Control V to stick it in this little box up here. And then press enter and it should go there. This is the field of view in the UV. We can see it in XMM. You can see it's a very hard source. It's very blue. And then, yeah, you can use Simbad on that one to go and find the information. So it was identified as a GBM source, but actually it is, so this is Fermi and it's a low mass X-ray binary. It's this source. They're both the same sources, but there's no identification for this one. And it's got the information, it's a low mass X-ray binary, that central source that we just discovered. So I have another example, but it's probably not worth starting that now. I can provide you, I'll provide you with the slides now. Correct that underscore error that was on there. But yeah, I'm happy to take some questions if there's any questions. I do understand that it was very, very quick. But yeah, then we can't do the next one in less than 3 minutes. So I can stop there.
Okay, thank you, Natalie.
No questions in the room?
Any question? Or
I have a question, but it's I got stuck at the beginning.
Yeah.
It's a silly question. Like how do you insert that that two greater than sign or end of the like those like that special symbol that I cannot find on my keyboard?
Oh, you
like
don't have it on
were,
your keyboard.
when
Okay.
when you were like
Doing the
marking the strings.
Yeah, this, like this, the greater than sign that's here.
Yeah, that's good.
Yeah,
This
so
this double like a greater, so it's a specific thing that I got stuck on that in the first.
okay. Yeah, so when I can't find a key, I won't share my screen again, but when I can't find
Did you copy and paste it from
yeah,
like
copy and paste it
website?
from the internet, find the sign
Okay,
on the internet and copy and paste. That's what I tend to do.
All right. Okay.
Yeah, sorry about that.
So this is the only way how it works, the TopCat.
No, absolutely not. So as I mentioned this morning, there's also stilts that you can program. TopCat, I just wanted to do it in a visual way this afternoon so that you could actually see what we were doing. But yeah, you can program TopCat with stilts. This programming language is fairly easy. It allows you to do that. You can see it once you start opening up the different boxes. There's a space, but you can also just send like a small program to TopCat in stilts.
Okay, thank you.
But as I say, you can also access the catalogs using Python or whatever else is your preferred way of coding. Okay, if there's nothing else, then I'll hand it on to the next person.
Okay, thank you, Natalie. So we move to the data lab tab. Okay, thank you. Do you have no questions? Or... So you all have the data lab account, so you can connect it, and you see the Teams workspace. You have your workspace. So what I would suggest is, I mean, for the people, I mean, the beginners, that is the first time you will deal with XML data. What I would recommend is to go to the threads. You should share your screen. Vale. Do you see the screen? Yeah. Vale, so what I suggest is to go to the source threads, this folder here, and copy all the directory to your workspace. You know, and maybe. No.
Yeah, show your screen.
So it's vale. Vale, so pero no funciona. Ahora,
You need to try here.
no, sometimes it's, I mean,
Maybe you can do the demo and I go around the floor.
sí, ahora sí. A ver. Vale, so if you go to data, can I do it? Vale. Vale. Data, SAS threads, W101. Vale. So if you, I would suggest to copy all this directory to your workspace. So you go to my workspace. I will create a new, just not to override any thing, and copy -R on this directory and add. And then you have a copy of the notebooks. Okay. And then you have the copy of the notebooks on your workspace. That I already have here. And then what I would suggest is to start with the first one, which is the startup thread. I would suggest you to read, because you can go cell by cell executing. It will work, but you have to understand what you are doing. Otherwise, it will not have sense. So I will recommend you to go, read the Jupyter notebook, execute the files. If there is anything that you don't understand, ask. And then when you download the data, that it will take minutes. You run zip-build or df-ingest, you will see this log. And when you reach the, you can skip this PPS section, vale? So you can start, the analysis of your source with the ODF, and then you get your event files. But you can also download from the archive the event file that it was created by the pipeline. So this is a way to download instead of the ODF, which is the raw data, there's the PPS data, the event file. So you can also do it. I mean, you can do whatever you want. We are here to help you, and if there is an error, ask. So, but if you download the ODF, you can skip these 2 steps, and then when you reach this point where you have to execute the procs, well, you can execute it. It takes, 10 minutes to run epproc. You can, you can do for epproc, for example, if you want, but you don't have to run emproc, rgsproc, and omnichel, because it will take 20 minutes. You can do it if you want, but when you reach this point, let us know, and what you can do is copy in the Teams workspace, Teams, ACME. Here I create this XMM data, which is the same folder as you will create when you will be executing in the Jupyter notebook. And in this directory is the ODF with all the analysis, with all the run, the PM, MOS, and RTS files. So you can copy this directory to your workspace, and then you don't have to run the epproc, and then you can go to the second my workspace, to the second thread, which is this one, how to filter from a particle value. And then you will use the same ODF, so you will have the event list there, and you can start filtering, and you can check the light curve, and you will see that in this particular case, you will see the image. In this particular case, you have this light curve, and as Camille and I mentioned this morning, you see that there is a period of time when there is a flare, so you will have to cut this flare with the 0.4 seconds to create this expression, and then you will cut these fading periods, and then you will see the image before and after. And then with this image that is clean, then you can extract the spectra and an icon. ¿Vale? So you start now, and let us know if you have any problem. And for this, if there are someone that has been dealing with XML data and he has some experience, we recommend you to go to the team workspace, ACME workshop, hands-on session, and here you have the two epic notebooks, one for this PKI source and another one for the Bella, the one that Camille mentioned this morning. So you can, copy those. Again, copy the directory with the tools directory as well. Copy to your workspace and start working with these Jupyter notebooks if you are more experienced. And if you want to deal with RGS, if you are interested in RGS and how to work with RGS, we have also this Jupyter notebook where you can do a more detailed analysis of this okay? So and you will see all the RGS, spectra, the images, and everything. So you have these 3 options. Beginners. The threads, if you have some experience and you want to deal with PM, go for the PM folder, and if you want to try RGS, go for the RGS folder. Copy to your home my workspace and start executing. And whenever you reach the point to run the props, if you don't want to wait 10 minutes, copy the XML data folder. Vale? And for the epic. For them, I will copy in the epic the result of the PKIs.
What are we supposed to see in the team workspace?
This. You don't see anything?
Like one folder only.
This hands-on session, you should see. You don't see it?
Yes.
In the previous folder?
This is what you're supposed to see.
Yes, you are.
Well, you don't see the XML stuff, probably because the right permissions.
Yes.
You don't see the Excel data. But you see the. What is your initial? So, you're there. Join. But then log out or log in or refresh. It's true that I just added before lunch, so maybe. So copy the notebooks. Copy the notebooks and start with the. If you want, we can go step by step. Executing it with you, but I think it's better if you read it, you execute it, you see what is going on, and if there is any problem, you let us.
And then when I
Sorry?
Yeah.
Excuse me?
Yes.
Yeah, can you show one more time the directory from where you copied that in that teamwork? Maybe I see like a little bit slower because I
The directory for the source threads or for the
yeah. For did you copy the it's because I have a feeling that I see much less files than you have there. And I was not sure which one was the right folder.
Wait. Could you repeat, please?
That I have a feeling that I have a feeling that I saw way less files and folders in that teamwork folder, and I was not sure if I see it correctly, which was
So
the file.
in the team folders, do you see the screen?
Yeah.
In the teams folder, you should see this
Right.
directory, ACME. If you don't see it,
okay, I see the workshop now. Yeah, now I see. Yeah, then.
And then inside there are two directories: hands-on session and XMM data.
Okay.
In the hands-on session is where we have, let's say, the
this one I see. And the other I didn't. So I was.
Okay, the others. If you go to your home, you click on this you go to data.
Okay.
SAS threads. And WA01. And then here you have this notebook version 1.0. So I recommend to copy all this directory because inside this directory you have the notebook.
Okay. Okay.
Let's say for beginners.
Yeah, now I see it. Thank you.
So copy this notebook, which is I think I did it here. Yeah, I did it here with this command. And then you start with the startup thread. This one.
Okay. All
You,
right.
I mean,
Yeah. Now I see. Thank you.
you're welcome. And any questions, Sam? I want to see a spectrum. You don't create a spectrum, you don't know. By default, I forgot to mention, by default, the CCF and the SAS thread are mounted by default. Don't check that you have those file systems in this node here. If you click it there, you will see that you have this. So by default, it's mounted, so you shouldn't do anything.
But in case you screwed up, it can delete.
For example, I don't know why it is not. You know. We see this model.
No, giusto per la
That one, yes. Vale, you run it. You this capture.
El workspace.
What is the path that you use? No, this is you don't know the Diez. Aquí es poniendo de bien data, now bien finished, now it's running more, so now you could start the second thread, but you have this is the same, this is just running. Because I mean, for this, you use the PM data. The PM data is already there. There's, I mean, there's one thing so there is one thing in this cell here, what is you have to define your working directory. By default, the working directory is your home plus this directory. So your home and XML data by default. Remember what I said, that the only directory that is persistent is my workspace. So if you don't add my workspace to this part, the directory will be your home directory, but it will disappear when the data lab is closed. Okay. So I will recommend you to add this my workspace. I mean, if you haven't done it, it's not a problem. You can go to the terminal and move the XML data to your my workspace, and you have it. But if you haven't executed this cell yet, add my workspace, and then you are sure that the data will be stored in the persistent. Yes, and then when you will execute each one, it's one, but when there's an asterisk, so well, it will take a while. But this one is finished. So you can now start with the second thread. That is, I mean, the trading party and balance, so they will use here. How to compare I mean, if you have executed.
Thank you.
Thank you, Aitor. No, you're welcome. See you around. If you have executed the probes, I mean, no problem. It will finish one day. I mean, 20 minutes, 30 minutes, will finish. So, but the important one, which is the epic probe, that is the one that creates the PM event list, is the one that you will have to use for filtering flaring particle background. So as soon as this cell is finished, you can move to the next one, which is this how to filter, because you have the event file, and then you can start filtering this event file, and you can leave EM probe and RGS probe running there on Omnichain, and you will finish. And again, the same here. You will have to tell. Here you will have to tell the Jupyter notebook where is your data. If you have added in my workspace, you will have to add it here as well. If you have it in your home directory, you don't have. But I mean, you have to specify where is your data. Vale? Okay. I'm going to.
Do they lose access to the team workspace once the workshop is over?
Sí, I mean, unless we tell data labs to remove it.
Once they created the ESA data labs account, they always had it. It's not temporary. There is a question about that.
Ah.
La seconda volta che ho partire, poi io ho fatto 2 volte e perché prima non avevo fatto una quindi si può. Wow, avanza. E qua è giù che no, la fonte spostata. Ma non è qua su my workspace. No, dopo adesso. Translate.
Do you have any error or whatever? Let me know. I want to see your spectra. Well, first I want to see this image filter. Yes, I mean, like, I mean, the Docker container is alive. So you can, the browser, you connect it and the distance is correct. And you can use it again. Eventually, after all the rest of the Docker container disappears, open a new Docker container, you are. Yeah, you don't try that. For example, I don't know if maybe you don't ship, for example, the GS9 with the online environment in your, yeah. I mean, what is supposed to in the near future? I mean, now you can have an account institution, and you also have an account as a developer. And with this, some other options, you will be able to make your own document. So then you can start this document, install your Python or whatever, create a new image, and then you use this one, and then we have
Did you create the PK? I don't follow. Did you create the PK?
Yeah,
Siamo al 31. Ancora una cosa. Perché vedi?
Ma solo di aiutare più No, you move the directory while the program runs. You are here, you have to check now that it's so then you run it again, because you already skip this one, you can skip this one. And check in the directory that you see all the files. You store. Yes. Ma come lo At the end, you do the spectrum and you do it's inside the I know I imagine this but it's all
so like now,
That's very wrong.
I mean, I was recommending an example. Is an example where you also this one. The PKS one, no, for the PKS, you have to go to the hands-on session folder and copy. Bueno, you can no. I mean, before the PKS, you can try the create an spectrum and the light, which is also part of the threads, and you also use the same ODF. Yeah. The 01. Yes, you use the 0104. And then you create an image. You will see the image here. You will see the image with GS9, and you have to create the subregion, the background region. One tricky, whenever you go to this create a spectra with GS9, you can click on here, you select the circle, you can zoom in a bit, so you can create the region. But if you here, although you don't see anything, there is another menu. If you with the two fingers to scroll down, and because this button here is important, because you create your source, then you create your then you click again on the circle, you create your background, put it here, and then you have to tell GS9 that this, for example, is the background, and you click on there. How to know that you did it right? If you double click in the region, you see here background. And if you double click in the source, you see source. And then in the next cell here, when you have to get the regions, because you have to tell GS9, tell me the regions to use it in the SAS command, you have to select both regions. Okay, you have to have the two regions selected, and then when you click on the get regions, when you execute this cell, you have the ID 1, which is the source. So but basically you have the two one. The ID 1, which is the source, and ID 2, which is the background region. And then internally, I mean, the Jupyter Notebook get the coordinate, the physical coordinate, these values here. There are these values here for the source, these values for the background, that later on you will use it to create the spectra and to create the log. So the only trick is to select the two regions. I think it's explained here. Select the two regions and this hidden menu that you can see it with the two fingers. Or also, I mean, you can also edit the source and write here background, and then GS9 knows there is a background.
After the break, we will present a tutorial, or we let people just read it.
Sure, you can. Sí.
And I can go quickly through
the Vela one. Sí.
That's the one I know. But, yeah, but maybe that's what you have been one hour.
I think it's better.
Yeah.
See that you can explain
Maybe
what.
for the people online that's more.
Yeah, about it.
Like for people who want in the room to do their things, they do, and then online they can follow me.
Yeah, we go cell by cell. What are we doing? But I think it's better for them.
I agree.
But yeah, we can do the Vela one for 30 minutes.
Yeah, voilà.
Yes, this is the why we have for.
Because
I mean, it's nice that you can execute cell by cell and it works.
I have more than 4.
Because for this particular observation,
There's a 4.
no, there are 4 exposures. So you have 4 event files. And because I mean this particular exposure, for whatever reason, I mean there was the observation had 4 different exposures. So you have 4 different event files. So when you go to the cell that you execute, you have a loop over all the 4 event files.
I think
You click it twice. But there are 4, they are not 8. So
Okay, yeah.
So the
No, it's battery.
So with the PKS example, I mean, in the PKS Jupyter notebook, you will see when you run epprop, you have 4 event files.
Yeah.
No, 3.
3 events.
3 event files. 3.
But now, like I said,
And yes, now we
the source and
yes, and you have the possibility to check. You can also say yeah, you can depends. In general, they do
no, I mean, I want to just going down. No, it's just a light.
No,
I don't know.
how can I do
Yeah, but if you want to go up and down, that's right. It's not easy to navigate.
There must be a way to.
Io ho capito, ma stranamente
Okay. You ready? Okay.
If the region is an analyst, also analyst,
You can use it as well.
but it doesn't find one.
Yeah, I mean, in the BKS, it's looking for an annulus. If you select a circle, you have to remove the second radius of the zero and check annulus by circle. When in the BKS one, because it was, I mean, no. By the BKS one, when of the light curve. Vale, here, I mean, you have your region that are circle, but then later on, here, I think this is the light curve. For the background, here for the background is the one that is used an annulus. So you have to change it. If you have selected a circle, change it to circle and remove the radio 2. So there is a radio 2 you have to remove, and it will work.
I wanted to use it.
Then you have to draw an annulus. When you have your image, I don't know why. Probably I lost it. Because then you have here the annulus.
But then when you say low,
it doesn't work. Radio 1 and radio 2.
I should go. It's the coffee break. 10 minutes.
Go for the coffee break, and we are back at 4 or 5 for it later on. So we go for a coffee break. Should we stop or? I will stop the.